So guys, what's up? This is your next lecture from Biomolecule, and this time it's about cellulose. What exactly you might remember about cellulose? That it is one of the most abundant, or I should say it's the most abundant polysaccharide or organic compound present on the earth. Why? Because it is present in the plants, and that's too in a very large concentration. How? That's very important. You do know that a plant cell has an additional covering apart from plasma membrane, and that covering is called cell wall, right? So a plant cell has double protection, dual protection. The innermost protection is called plasma membrane and the outermost protection is called cell wall. So what that means, each and every cell has a cell wall in the plants, and that cell wall is made up of nothing but cellulose. And that's why cellulose is most abundant chemical substance on the earth, naturally, right? Now, why we are here, we can take this topic in terms of bio, in terms of chemistry, because this is something common in both. But what chemistry, your book actually have about cellulose is that it is most abundant substance. I have written a couple of lines here, already, because just a moment back I was making, a Hindi, lecture for the cellulose, and while doing so I wrote this, statement. So I'm going to repeat this statement so that you can directly copy that in case you need. The first thing is that, don't get over this one, because I will explain you what this is later on structurally. So the first thing about cellulose is that it is most abundant organic compound. Second, it is present in cell wall of plants as a constituent, as a cell wall constituent it is present. Third, it is a polysaccharide and it is made up of beta-D glucose only. Right? So this is the important thing. Cellulose is made up of linear chain of beta-D glucose. Right? It's a linear chain, and millions and millions of molecules of beta-D glucose, when linearly linked together, they form this cellulose. Right? So it's a polymer, it's a macromolecule. The fourth statement is here is that this cellulose has a glycosidic linkage between the beta-D glucose, and that glycosidic linkage is between the first carbon of one glucose between, let me repeat back, this is really important. The glycosidic linkage in the cellulose is involving first carbon of one beta-D glucose and fourth carbon of next beta-D glucose in the line. And that's how the first and fourth, of two beta-D glucose combine to form a glycosidic linkage, and that's how a numerous, or a large number of bond formation result, formation of cellulose. But like you also know that this bond formation also involve, removal of water molecule, and that's why this process is again, you can call it dehydration synthesis. So I'm going to make you go, by drawing the structure and helping you how cellulose is formed exactly. So in order to do that, I'm taking this beta-D glucose right here. Just pay attention, this is really important. So this is your beta-D glucose. A beta-D glucose has a difference, when you compare it with the alpha. And what that difference is, this first carbon configuration, which is also called anomeric carbon, it is different. What is the difference here? It has OH up here. It has OH up here and H down here. But in alpha, OH is down here and H is up there. So that's the difference. Rest is all the same. So this is going to be OH here. This is your H again. The third one has H outside and OH inside. Similarly, this one has OH out and H up here. And this last one is nothing but a achiral carbon, CH2OH with H, inside the ring. So this is your first beta-D glucose. Let me write this here. This is your beta-D glucose. right? Let's draw the second and third, and then I will make you go understanding this glycosidic linkage involving first and fourth. So this is your second one, right? So again you have to draw the same structure like this one. So what it's going to be, this is what it looks like. You have six membered ring here, with second one is having OH out, H inside. This one has OH, which is the first carbon, OH up, H down here, and H out here, while OH is inside on the third carbon. And there is again your OH, and this is your H. Similarly, this is your A chiral carbon CH2OH with one hydrogen inside. So this is your second molecule of beta D glucose. Beta D glucose. Right? Let's draw another one and then understand what the linkage looks like to be. So this is your third molecule of beta D glucose. Third molecule of beta D glucose. So you have to copy everything just like the second and the first one. So this is what it looks like to be, CH2OH. There you have OH up here. Similarly, this is H. You know what? Once you do something like this, you repeat several times over a topic. This is, how exactly you can memorize it for a real long time, or I should say for always, right? So if I remember, I have done maybe more than 50 times, almost like 50 times, drawing the same structure. So if you practice that way, you also remember just like that, the way I'm doing right now. So this is your OH out here, H in here. This is your H out here, OH in here. There you have your OH here, OH, and there is your H here. So, and you can also place one hydrogen up here. So these are the three molecules of beta D glucose I have. So beta D glucose. Just don't criticize over my handwriting, because that's not something I can change. Okay. So now concentrate. This is something again you are going to go through, that the glycosidic linkage here is forming involving OH from one glucose and OH from one glucose and H from another glucose. You can take any one hydrogen and any one hydroxide. So I am taking OH of this one with H of this one. So what happens? This result formation of a water molecule. And if the water molecule is formed, what will happen? This oxygen will form a glycosidic linkage here, which going to look like something similar to this. So this is the glycosidic linkage between the fourth carbon of this glucose and first carbon of that one. Similarly, we will do the very same right here. So this is OH out, H in here. They will result formation of a water molecule, and apart from that, again you can draw, there was oxygen, so that oxygen will be responsible for, making the glycosidic linkage. So this is how the glycosidic linkage will be forming, right? So this is again your fourth carbon, and there your first carbon, right? And this way, it result adding more and more number of glucose, beta D glucose in the sequence, and that's how cellulose is formed. Right? Let me repeat back. A cellulose molecule is formed by, a number of glycosidic linkages that develops between, two adjacent beta D glucose molecule, right? And that's why the bond you need to remember is between first and fourth. First carbon of one beta D glucose and fourth carbon of next beta D glucose. Now, a very important question is still remaining, and that is, if cellulose is reducing or non-reducing, right? So this is what we have to talk. That's going to be very important. If you remember, I told you that in order to be a sugar, in order to be a disaccharide, either reducing or non-reducing. For being reducing, it has to has OH. It should also have H. And apart from that, it also have ether. So what it looks like, that this very first carbon of the end one, right? This end one is having OH here, H here and ether here. So this looks like a reducing sugar, but this is not a reducing sugar. In fact, it's a non-reducing. Why? Because this is not the glucose molecule at the end, because there are millions and millions of molecules in the chain. So in order to justify yourself that the cellulose is a non-reducing, you have to look out over this one. So you have to look out over, this molecule of glucose, where you don't see any carbon with this configuration. This hemiacetal configuration is nowhere on the middle glucose, on the central glucose, and that's why, because it lacks the hemiacetal structure, and hence you can consider this cellulose as a non-reducing, right? In case you need, just repeat the last few minutes, and then you again going to be, happy with, everything I said. So with this, I must, wind this here, and I would say thanks for watching, take care and good night.